When you download the Baker's app, you have easy access to savings every day. Get the most out of weekly sales and receive personalized coupons to save on your favorite items, all while earning 1 fuel point for every dollar spent. Baker's makes it easy to save while you shop, whether it's in-store or online, so you get the most value out of every trip, every time. Download the Baker's app now to save big on your next purchase. Baker's, fresh for everyone. Must have a digital account to redeem offers. Restrictions may apply. See site for details.
Hello and welcome to another episode of Astronomy Daily. Steve Dunkley with you for another episode. It's the 10th of July 2023. Thanks for coming with us.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
That's right, and with me as usual is Hallie. How are you, Hallie?
Hi, good to be back. How was your birthday celebration, Steve?
Oh, Hallie, some events should be left to fade into history.
And shall not be spoken of again.
Too right. So tell me, what have we got on for today?
Well, a huge piece of granite found on the far side of the moon is giving researchers clues about ancient lunar volcanoes. Can you imagine what that must have been like?
Well, I was at this party recently, but I do have a story about what the Chinese rover is discovering about the Martian climate a long time ago.
That sounds cool.
Well, I think there is an ice age involved, yes.
And the James Webb Space Telescope has detected the oldest strand of cosmic web ever.
Wow, that must really be old.
Like, older than 60 years old, Steve.
Yeah, way older, Hallie. And did you know there's a storm forecast for Thursday night?
Yes, but it's a solar storm and it's going to give us a light show worth waiting for.
Anything else off the wire?
Just one other story. It looks like the Pentagon is doing that deal with SpaceX and supplying Ukraine with internet systems after all.
Well, I hope that does some good. Meanwhile, on with the show, Hallie.
Okay, here's the bits and pieces. A large formation of granite discovered beneath an ancient lunar volcano is further evidence that the far side of the moon once glowed with volcanic eruptions. The granite was found under a suspected volcanic feature on the surface of the moon called Compton-Belkovich. This feature was likely formed as the result of cooling magma that fed fiery eruptions of lunar volcanoes around 3.5 billion years ago. Finding the remains of volcanic activity in this region of the moon isn't completely unexpected, as researchers have long suspected this area to be an ancient complex of volcanoes. What has come as a surprise to the team, however, is just how large this patch of cooled magma is, with an estimated width of around 31 miles or 50 kilometers. The discovery of this large body of granite beneath the Compton-Belkovich volcanic complex could help scientists explain how the lunar crust formed in the moon's early history. The Pentagon has confirmed it is buying SpaceX's Starlink broadband services to provide communications in Ukraine. Elon Musk's SpaceX has been supplying Ukraine with Starlink terminals since the Russian invasion of the country in 2022, providing vital communications after the destruction of infrastructure within the country. However, SpaceX stated in September 2022 that it could not continue funding the Starlink service for Ukraine, and had asked the Pentagon to step in and cover costs. A deal is now in place to provide the vital communications services. The Pentagon did not reveal details of the contracts, citing operational security concerns. A solar storm forecast for Thursday is expected to give skygazers in 17 American states a chance to glimpse the northern lights, the colorful sky show that happens when solar wind hits the atmosphere. Northern lights, also known as aurora borealis, are most often seen in Alaska, Canada, and Scandinavia, but an 11-year solar cycle that's expected to peak in 2024 is making the lights visible in places farther to the south. 3 months ago, the light displays were visible in Arizona, marking the third severe geomagnetic storm since the current solar cycle began in 2019. The Geophysical Institute at the University of Alaska at Fairbanks has forecast auroral activity on Thursday in Alaska, Oregon, Washington, Idaho, Montana, Wyoming, North Dakota, South Dakota, Minnesota, Wisconsin, Michigan, New York, New Hampshire, Vermont, Indiana, Maine, and Maryland. Auroral activity also has been forecast for Canada, including Vancouver. Light displays are expected to be visible overhead in Milwaukee, Minneapolis, and Helena, Montana, and low on the horizon in Salem, Oregon, Boise, Idaho, Cheyenne, Wyoming, Annapolis, Maryland, and Indianapolis, according to the Institute. The National Oceanic and Atmospheric Administration Space Weather Prediction Center said people wanting to experience an aurora should get away from city lights and that the best viewing times are between 10 p.m. and 2 a.m. local time. Northern lights occur when a magnetic solar wind slams into the Earth's magnetic field and causes atoms in the upper atmosphere to glow. The lights appear suddenly and the intensity varies. That's it for me. Back to you, Steve.
Roger that, Control. We're listening to Astronomy Daily, the podcast.
Yes, thanks again for joining us on Astronomy Daily. Don't forget you can catch Tim Gibbs on Fridays, myself on Mondays on this podcast, Astronomy Daily. Also, the parent podcast is Space Nuts, all of which you can find at spacenuts.io or at bytes.com. Space Nuts is, of course, compared by my big brother, Andrew Dunkley, and, of course, Professor Fred Watson. Go to spacenuts.io and you can hear all of the episodes past and present. On a clear night, it might seem like the stars above are distributed more or less evenly, but that, of course, isn't the case. All stars are part of a giant cosmic web that links galaxies across the universe like threads of a spider's silk, leaving unfathomably large swathes of nothingness in between. Now, in two papers published in the Astrophysical Journal Letters on June 29, scientists detail evidence that this massive cosmic highway stretches back nearly to the dawn of the universe. Using data from the James Webb Space Telescope, astronomers discovered a massive gassy tendril composed of 10 closely packed galaxies stretched over 30 million light-years. According to the researchers, this filament is ancient, made of gas and stars, and may represent the oldest known thread of cosmic web. I was surprised how long and how narrow this filament is. S02E18, Fan, an astronomer at the University of Arizona and member of the research team, said in a statement, "I expected to find something, but I didn't expect such a long, distinctly thin structure." Now, before we go on with this new discovery, it might be noteworthy to have a look at S02E18 Fan. Born in November 1971 in Beijing, China, he's an American astronomer and full professor at the University of Arizona and widely known for his studies on quasar. Extremely bright supermassive black holes detected primarily at the high redshift. In 2003, Fan was named to Popular Science magazine's annual Brilliant 10 list for developing methods to investigate distant quasars. Since 2001, he was a pioneer in the detection and discovery of high redshift quasars, including new techniques and practically inventing the field. Using these quasars, he has shown that supermassive black holes with masses up to 10 million solar masses existed within 1 billion years after the Big Bang. And in 2019, he led an international team of astronomers that discovered the farthest lensed quasar so far, the very first epoch of reionization. And in 2021, his team announced the discovery of the most distant and oldest known quasar, QSO J0313-1806. Now we know exactly who we're talking about. Back to the show. This newly discovered filament apparently formed when the universe was very young. It's anchored by an extremely bright celestial object with a supermassive black hole known as a quasar at its centre. This bright black hole is the reason scientists discovered the tendril in the first place. Fan and his team are working as part of the ASPIRE, that is, a spectroscopic survey of biased halos in the reionization era project, which aims to study how the earliest black holes influenced galactic evolution. The quasar detected here was one of 25 early universe quasars that the project has its sights set on. This is one of the earliest filamentary structures that people have ever found associated with a distant quasar, said Fei Zhuang, an astrophysicist at the University of Arizona and the program's principal investigator. The researchers hypothesized that these black holes help to form the cosmic web by acting as gravity wells to draw matter together, and occasionally by flinging it far away on cosmic winds, which whip up around extremely active quasars. Gravity keeps these strands of stars and dust connected, even as the winds pull them across the universe. The researchers think that eventually the filament will condense into a cluster of galaxies similar to the Coma cluster, which lies approximately 330 million light years from Earth. And it looks like the climate of Mars has dramatically changed somewhat. Only it happened 400,000 years ago, according to Chinese researchers. China's Zhurong Mars rover has found evidence of a dramatic shift in Mars's climate 400,000 years ago in the form of dark ridges laid on top of bright dunes that ripple across the sands of Utopia Planitia, which the rover is exploring. Scientists from the National Astronomical Observatories of the Chinese Academy of Scientists use the rover's instruments coupled with high-resolution observations from China's Tianwen-1 Mars orbiter to take a closer look at the large sand dunes near where Zhurong landed in May 2021. The crescent shape of the dunes has been eroded over hundreds of thousands of years, with long dark ridges called transverse aeolian ridges, TARs, forming on the tops of the dune fields, but apparently at different angles than that of the wind-blown dunes. TARs have been observed all across Mars at lower mid-latitudes, but global atmospheric circulation models that describe the direction of the winds on the red planet have been unable to explain how the features could have formed. That is, until now. Zhurong's investigation of the dunes found that their crescent-shaped bodies are made of brighter material underneath the darker material that forms the TARs. From orbit, Tianwen-1 observed 2,262 bright dunes across Mars, and based on the number of craters that have impacted on top of the dunes, the research team estimates that they formed between 2.1 million and 400,000 years ago. That means the dark TARs must have formed on top of them within the past 400,000 years or so. These dates coincide with the start and end of Mars's last major ice age. For the TARs to have formed at a different angle to the dunes implies that the wind direction in the lower mid-latitudes must have changed with the end of the ice age. The ice age began and ended because the changes at the angle at which Mars spins, brought about by Milankovitch cycles. These cycles involve a periodic wandering of a planet's rotational axis relative to the plane of its orbit, caused by a combined effects of gravity, the Sun, Jupiter, and other planets, as well as the shape and precession of the planet's orbit. Both Earth and Mars experience these cycles, which correspond to climactic shifts. In the case of Mars, its angle of rotation, referred to as its obliquity, varied between 15 degrees and 35 degrees between 2.1 million and 400,000 years ago, playing havoc with its climate. Today, Mars's obliquity is about 25 degrees. Somewhat surprisingly, an ice age on Mars is not quite the same as on Earth. Typically, Mars ice ages see warmer temperatures at the poles and movement of water vapour and dust toward the mid-latitudes where they are deposited. During the last ice age, this water and dust formed a metres-thick layer that still remains beneath the surface in selected locations below 60 degrees latitude and almost everywhere above 60 degrees. The current geological era on Mars is known as the Amazonian epoch, which began sometime between 3.55 and 1.88 billion years ago and is defined by the number of impacts over that time. Observations of the current climate of Mars can help refine physical models of Martian climate and landscape evolution, and even form new paradigms, researchers said. Meanwhile, the Zhurong rover entered hibernation during Mars's long northern winter. It's yet to reactivate, but its fate actually remains a little bit uncertain.
That sounds sad. That poor little rover.
Oh, well, Hallie, you could start a GoFundMe page and maybe inspire some of those bored billionaires to get involved in the space race. Maybe go and rescue that poor little rover.
I could, but then again, nah.
Well, and just like that, Hallie brings us to a screaming halt. Thank you for joining us again for Astronomy Daily. I'm Steve Dunkley, your host, and that was Hallie. Thank you very much. And we'll be back next week. And don't forget, Tim Gibbs, all the way from Bath, England, on Friday. And we'll be looking forward to finding out what's happening in your skies. See you all next week.
See you later, everyone.
Astronomy Daily, the podcast, with your host, Steve Dunkley.